Hey there, P7 candidates. Welcome to today's explainer. I am absolutely pumped to have you here. Look, together we're going to master a super important math topic for your primary leaving examinations, sets. We'll take it step by step so you fully grasp every single concept. So grab that notebook because we're going to make this completely painless and, dare I say, actually kind of fun.
Okay, so here's our game plan for today. We're doing a quick revision on the basic types of sets, then diving into the empty or null set, finite and infinite sets. After that, we'll tackle equal versus equivalent sets, wrap up with disjoint sets, and finally hit you with a quick final challenge. Section 1, Revising Types of Sets. To kick things off, we're going to use everyday stuff you see around the classroom or at home, things like ropes, cups, balls, and books, just to help us picture these math concepts right in our heads. But before we get into the different types, I've got a quick question for you. What exactly is a set? Seriously, try to define it in your head right now. I'll give you a quick second.
Okay, did you say a collection of well-defined things or objects? If you did, spot on, you nailed it. A set is literally just a group of things that are clearly identified. And remember, the items inside a set are called members, or elements. So today, we're looking at all the different ways we can group and describe these collections.
All right, moving on to section 2, the empty or null set. So imagine I hand you a basket, right? But when you look inside, there is absolutely nothing there. Zip. Zero. What do we call a set with absolutely zero items inside? I bet you can guess the two special names we use for this one.
The answer is, well, wonderfully simple. It's called the empty set, or the null set. It's simply a set that contains no members at all. Just like an empty plastic cup sitting on your desk, it holds nothing. If you're asked in your PLE to give an example, you could say, a set of primary 7 students with 10 heads, right? Since no student has 10 heads, at least I hope not, that set is completely empty.
Okay, section 3, finite and infinite sets. This part is all about how we count the items or members inside our sets. Here's your next question. When we talk about a set of items, what does the word finite actually mean? Think about counting objects. When is a set considered finite? Take a brief moment and think about it. So a finite set is a collection where the members can be counted. And here's the key. The counting actually comes to an end. You can finish counting them. For example, say we have a set of 5 books on a desk, or a set of 3 footballs in a field. You count 1, 2, 3, and boom, you stop. Because the counting ends, it's finite. Now, I want to challenge you. If finite means the counting comes to an end, what is the exact opposite of that? What's an infinite set? An infinite set is a set where the members cannot be fully counted. The counting literally never ends. It goes on forever. For instance, if you tried to count a set of all the numbers in the world, 1, 2, 3, a million, a billion, you'd never, ever finish. That is what makes it an infinite set. Let's compare them side by side. Finite sets, the counting ends. Infinite sets, the counting never ends. Please lock this comparison into your brain for your exams, because examiners absolutely love to test if you know the difference between a set that stops and a set that goes on forever. All right, section 4, equal and equivalent sets. Now, I've got to warn you, my dear candidate, these two words sound very, very similar. But in math, they mean two completely different things. Let's make sure you don't get tricked. First up, let's look at the word equal. What do you think must be true for two sets to be called perfectly equal? Take a guess. Equal sets are sets that have the exact same members. They literally must be identical. If set A has a green cup and a jumping rope, well then set B must also have that exact same green cup and jumping rope. It doesn't matter what order they're in, as long as the items are exactly the same, they are equal. Okay, so if equal means the exact same items, what makes two sets equivalent? How is that different from what we just looked at? Equivalent sets are sets that simply have the same number of members. The items inside do not have to be the same. We only care about the total quantity. So, for example, if set A has 3 jumping ropes and set B has 3 footballs, they aren't the same objects at all, but because they both have exactly 3 items, they're equivalent. So, here's the crucial trick to remember. Equal sets must have the exact same items. Equivalent sets just need to have the same number of items.
If you have 5 books and I have 5 cups, our sets are equivalent, but they are not equal. This is a massive trick in the PSLE curriculum, so make absolutely sure you keep them straight.
Moving right along to Section 5, disjoint sets.
Imagine you've got 2 groups of things. One group of things is over here, and the other group is way over there. They share absolutely nothing at all. What do we call this situation in math? We call them disjoint sets. Disjoint sets are sets that have no common members. They just don't intersect. If set A is a set of math books and set B is a set of drinking cups, they're totally disjoint. A book isn't a cup and a cup isn't a book, right? They share absolutely nothing. And finally, Section 6, the final challenge. Huge congratulations to you. We've covered all the major types of sets in the P7 syllabus today. You've been doing awesome. But before you go, it's time for a quick test of your knowledge. Here's your question to think about. If set A contains all the stars in the night sky and set B contains absolutely 0 items, what specific types of sets are these? Think back to our lesson. I'm going to leave you with that provocative thought to test your revision. Keep practicing your math, stay focused, and I wish you massive success on your PLE. Catch you next time.